nearest value system. It says this is the method of approximation with reference to unit of measurements. Example in centimeter, in meter, in kilogram, in grams, in kobo, naira, and or specifications like whole numbers, units, digits, tens, tens of thousands, tens of tens, and so on and so forth. Now let's look at example. Now look at these ones. The first one says, example, correct, number one says, correct 153.58 to A to I, the nearest tens, I to the nearest 100. That is 1I, which is 153.58. You remember this thing we did, it's not in primary, not at the primary school. 100 tens units. They have tens, tenth, 100, 1,000, and then so on and so forth. So if you want to place these numbers now, 1 will be under 100, 5 will be under tens, and the 3 will be under units. While 5 will be under tenths, and 8 will be under hundredths, and then so on and so forth. Now from here now, if you want to, they said you should approximate it to the nearest tens. Now looking at this thing now, the nearest tens, the tens value here is 5, right? So if you want to approximate it to the nearest tens, what will you do? The 100 will be there, 5, which is tens, will be there. Then if you go to unit digits, look at the number that is here. Is it up to 5 and above? If it is not up to, you ignore it. That means this is 150. Nearest tens. 1 is under 100, not hundredths. Remember the difference. Hundredths is after decimal. The 1 is under 100, 5 is under tens, 3 is under units, 5 under tenths, hundredths, thousands. And we're asked to express to the correct to the nearest tens. So first one must be there, of course. Then number under tens is 5. Now you write 5, the unit you approximate if there's need, and then you got 150. Now the second one, II, is to the nearest what? To the nearest 100. Now, looking at that one still, the value that is under 100 is 1. But then, under tens, we have 5. So this number to the nearest 100 is equal to what? Okay, 153.58 is equal to 200 to the nearest 100. To the nearest 100. See how we got it? Number under 100 is 1. Of course, that one is there already. Now, when you go to the tens digits, the number there is 5, and of course 5 is up to 5 and above. So you approximate it. Once you approximate it and call it 1, when you put it here, it becomes 2. This is 2, others 0, 200 ones. So and you know that any number, point, any 0 after point, if there's no other number at the back, those numbers are just like no number. For instance, we have 22.0. It's the same thing as 22. But if it is 22.03, it is not the same thing as 2222. These two things, this is not the same thing with this, but this and this are the same thing. Reason, there is 0 after, there is 3 after 0, so you cannot just ignore this 0. So note that. So if you notice this place, even if we put 0.00 in all these ones, they are just 0. Then another one, it says correct, that is number 2. It says correct 6, 5, 7. And of course, we consider that 100 tens units. We have 6 under 100, 5 under, and this 7 under units. And then to the nearest, you notice that number, which is 6, 5, 7, will be equal to the nearest 100 will be equal to 700 to the nearest 100. To the nearest 100. Why? Like we used to say, the number under 100 is 6, and the number under tens is 5. Approximate it and call it here, and when you put it here, it becomes 7. That is 700. And then the last one is that we should correct this one to the nearest hundreds. Know the difference between 100 and 100. So we will now have tens, units, tenths, hundreds, thousand, then tens of thousand, tenth of thousand, and then tenth of thousand, and then okay, we are now placing the numbers. Of course, for here there's nothing there. We have 1 under units, 0.3462, right? 1 is under units, then we have tens, all these ones. Now they said we should correct it to the nearest hundreds. Now of course, you know this one will be there already, this one will be there, and this one will be there. And then this hundreds, then the number is up to 5. So 1.3462 is equal to 1.35 to the nearest hundreds. So that is it. Okay, now remember the one we did here is for specification. Now for units of measurements, for units of measurement, for unit of measurements, kilometer. Whenever you hear about, whenever you're asked to find number to the nearest kilometer, it's always the same thing to the nearest 1 kilometer. The nearest 1 kilometer, which is the same thing as to the nearest unit digit, which is the same thing as, which is nearest unit digit. Nearest kilometer. This, what of nearest 10 kilometer? Nearest 10 kilometer is the same thing as the nearest 10th digit. Nearest 10th digit. And then nearest 1000 kilometer. Nearest 1000 kilometer is to the nearest. The nearest 100. Sorry, this 100 first. Nearest 100 kilometer equals to the nearest 100 digits. 100 digits. Now, what of to the nearest naira? So I ask to get the value to the nearest naira. Nearest naira. That is to the nearest 1 naira. That is to the nearest 1 naira, which is to the nearest unit digits. Nearest naira is to the nearest 1 naira, which is to the nearest unit digit. Now, nearest 10 naira. Nearest 10 naira is equal to the nearest 10th digit, and so on, and 10th digit, and then so on and so forth. So let's look at example from this one. Now look at the example. It said express 1,444 kilometers to I to the nearest kilometer, I to the nearest 10 kilometer. Now from there, that's number 1 1444 kilometer is equal to, and now like we said, to the nearest kilometer is to the nearest unit digit, that is the nearest 1 kilometer. And here now, what is the unit digit? This is 100, 1,000, tens of thousands. So this value will be equal to 144. This is the unit digit 4. This is 144 to nearest 1 kilometer, and that's a number 1444 kilometer is equal to, now to the nearest 10 kilometer is equal to 1440 to nearest 10 km. This is tenth of thousand, this is 1,000, 1,444, this is 1,000, 100, tens, then units. So the nearest 10 kilometer is here, consider here. Then the other one is not up to 5, so we will leave it as 0. And then 1444 kilometer is equal to, this one now is to the nearest 100 kilometer, is equal to 1400 to nearest 100 kilometer. And then number 2, that says express this thing, express 6.4 seconds. This is seconds to the nearest second, and that is equal to number 2. 6.4 seconds is the same thing as 6 seconds. All right, 6 seconds to the nearest second. To the nearest second. Why? Of course, to the nearest seconds is to the nearest 1 second, and that 1 second is to the nearest unit digit. And then the only unit digit we have here is 6. So 6.0, which is 6 to the nearest second. Now, the last one is standard form. This is a system of approximation where a number is written as a multiple of the powers of 10. Okay, example, write in standard form. The first one is 12.36, and that is the same thing as 1.2324 times 10 raised to power 1. How? Now, the point is moving to the right, of course. So we have 1.24. It was in 2 decimal places. That's why we left it 2 decimal places times. The point only moved once before it arrives to the last place, the second to the last place. So because it moved once, it is raised to the power 10 raised to the power of 1. Now the second one now, 2, which is 1457. This is the same thing as 1.457 times 10 raised to the power 3. How? Looking at this one now, the only place we assume that is dot is 1457.0. So the dot is at the extreme end here. So, and the dot moves how many places before it arrives to here? Moves 1, 2, 3. So that's why we wrote it as 1.457 times 10 raised to the power 3. And then the last one is 0.152, and this is the same thing. This is equal to 1.52 times 10 raised to the power minus 1. Now, how? This one, the point is not moving left, the point is moving right, and because it's moving to the decimal side, that is why it has the power of minus 1, and it moves only once. So we have 1.52 to the power of minus 1. So that's it for approximation of numbers. Thank you for your active participation.